Assalamualaikum and hi. I represent the leader of Group 9. We'll present the project that has assigned to us. So before we start the presentation, let me introduce our group member. First one is Muhammad Nur Azmizi bin Razak. Second one, Ashraf bin Nur Hisham. The third one, Muhammad Aizuddin bin Muhammad Suhaimi. The fourth one, Muhammad Zulhelmi bin Muhammad Nazli. And the last one, Muhammad Aiman Ashraf bin Muhammad.
Assalamualaikum warahmatullahi wabarakatuh. This is introduction from chapter 1. Air Pollutant Index (API) is used to describe the measurement of ambient air quality in Malaysia and is also designed in easily to understandable range of values to report the air quality. Next, this is the way to obtain the data. First, we open the data set of air pollution index in that website, and we take the data in Kanga Perlis from January to July 2019. Next, we record the air pollutant index in the table by using Microsoft Excel. And the last but not least, we create the table that is CAQM index for API PM 2.5 that you can see in the next slide. So this is the results that we get from the data, and we calculate the average in each month from the January to the July. So this is our graph. We get the data from the table, and the red line is our guideline in Malaysia. So from the data and the graph that we get, we can conclude that first, the black line is the CAQM index for API PM 2.5 in Kanga Perlis. For the red line is the new Malaysia ambient air quality standard, and the data we also can conclude that all data are above than the Malaysia ambient air quality standard, that is 15. In addition, there are a lot of causes that make this data is higher than API standard in Malaysia. The first one is open burning activity. This activity is made by the lack of knowledge person about pollution. And the second one is there are a lot of vehicles users, and it can cause the production toxic and pollution gases. And the last but not least, irresponsible industrial parties that they don't care about the pollution, they just want their money.
Hi, my name is Muhammad Aizuddin bin Muhammad Suhaimi. So today I will explain about the project 2. So this is our introduction. The way traditional to visually represent the wind condition, direction and speed over time at a particular site is using a wind rose. A site average wind direction and wind speed statistic are logged over time, such as 1 week, 1 month or longer than that. Display the frequency wind coming from various direction is in circular form. In this study, our group has chosen the Bukit Pasir Muar Johor. Next part is methodology. There are two parts to build Windrose, which is first obtaining the data. First one is open website Meteo Trend, which is this website will show you the direction, wind, speed all around the Malaysian place. The second one is choose place to get the data, which is our group choose Bukit Pasir Muar Johor. Step 3 is record the data into the table Excel. Next, convert into radar chart. Step 1, table data must be converted into pivot data. Step 2, which is a column classification, which is wind direction, must go into columns and values, and wind speed in the rows. So the step 3 is the result of the step 2. Step 4, which is we need make them as a group. So we decide to do a 6 group of the row labels. Step 5, data should show as a percentage. So the step 6 is the result of the step 5. So next is step 7, which is make another table. So copy all the table step 6 and then paste in the below. So step 8, we need to rearrange the direction wind, same as compass. So step 9, select the data and then convert into radar chart, which is there are features in Excel. We'll recommend you the radar chart. So step 10, the chart is complete.
Okay, as for the result and analysis, the wind rows contain wind speed classes and the distribution of wind direction. As the color of the line represent the wind speed and the direction shows the distribution of the wind through the area. We continue for the first graph, which is distribution of wind speed classes. So the graph above shows the data collection for wind speed classes and the percentage. So the highest percentage for wind speed is 4 to 6, which is 34.69%. We continue for the second graph, which is distribution of wind direction. The data shows percentage of wind direction, and the highest is north, which is 40.82%. As we can see that most of the wind direction is towards to the north. So we continue for the conclusion for project number 2. The wind rows shows the whole of Bukit Pasir have an average wind speed of 4 to 16 miles per second, and the north had the highest frequency with 40.82%, and also most of the wind direction is towards to the north.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Ashraf bin Muhammad, metric number AN200006, and I will present about Project 3.
And now I will start my present with the introduction. Basically, this project uses online application that called ToxFlame, which is a web tool for air quality modeling. ToxFlame is an evolution of the MRBT analytical dispersion model. According to Bianconi and Tamponi, ToxFlame is a software code based on an analytical solution to the atmospheric dispersion equation for inert substances that may undergo a first-order chemical or physical decay and have a density that is similar to the air density. An analytical model called ToxFlame describes how inert gas dispersion occurs in the atmosphere. It is based on an original generic solution to the diffusion equation that accounts for immediate, variable, and infinitely long releases. The highest concentration at each place, the concentration field at specific times, and the average concentration over a limited time are all calculated by ToxFlame. ToxFlame contains algorithm for calculating the classical plum rise from stacks, and also the plum rise from coal fires. It is also possible to specify an effective release rate. ToxFlame extrapolates the wind speed at the release height according to a vertical profile that depends on land characteristics through the roughness length parameter and the atmospheric stability.
Move to the objective. There are two objectives of this project. The first one is to show the effect of parameters to the concentration of pollutants dispersion by using ToxFlame online. And the second one is to observe the change of parameter with the change of air pollutant concentration found from the software in Google Earth. The next part is about results and analysis. From the ToxFlame application that we have used, we have chosen example 2 as a subject to carry out this project, where the situation for example 2 is winter situation. So as we can see in the table on the left is the data for example 2, which consists of various elements and their values. For example, the wind speed is 1 meter per second, the wind direction is 234 degree, anemometer height is 10 meter, 2 Celsius for the temperature, 200 meter for the mixing height, and the last one for the Pascal Gifford stability is E, that is stable. And while for the picture on the right is the aeration after we entered the given data into the Google Earth software. In the picture, there are many grids shown, where the grid represent the concentration in the area. The concentration in each area is different, and it is classified into three ranges according to color. Namely the red grid for the low concentration range value, the green grid for the medium, and the last one is the blue grid that shows the highest concentration value. The unit for the concentration is in units of Ug per meter cube. And this is the value for each interval in red grid, green grid, and blue grid. Lastly, this is the enlarged image for the each part of the color of the grid, which is for the red grid, the green grid, and blue grid. I think that's all from me. I will pass to Zulhemi for the next part. That's all. Thank you.
Okay, next we learn how parameter affect the concentration of the pollutant dispersion by altering one parameter at a time while the other parameter remain constant. So this picture shows the result of the varying the wind speed from 1 meter per second to 3 meter per second. So with the same parameter, which is 234-degree wind direction. So this picture shows the red grid is spreading out further, and we can see that it shows 34 total of red grids, 3 blue grids, and also 4 green grids. Next, we change the wind direction from 234 degree to 180 degree. As you can see, the pollutant dispersion are changing into a straight line following the 180 degree. Other than that, the amount of red grids are only 11 and the dispersion are not that wide. So next, this picture shows the effect of changing temperature. So we change the temperature from 2 degrees Celsius to 15 degrees Celsius. So the pollutant dispersion remain the same as the first observation, and also the spread is also the same. So next, this picture shows the effect of the concentration of the pollution dispersion if there are changes in the mixing height. So we change the perimeter from 200 meter to 500 meter. So as you can see, there are big difference from 200 meter to 500 meter changes in this picture. There are increase in red grids, which are 186 red grids, 6 blue grids, and also 10 green grids on this side. So lastly, this picture shows if there are any changes in Pascal-Gifford stability. So the official stability is E, which is stable, and we changes it to F, which is extremely stable. As you can see, there are also big difference from the first observation. The amount of red grids are increased about 70, and the blue grids are 5, and there are 2 green grids in this picture. So in conclusion, the factor including wind direction, mixing height, and Pascal-Gifford stability have a significant impact on the concentration of the pollutant dispersion on the site observed.